Now, let's think bigger and broaden our horizons. In fact, let's just destroy the event horizon. Yes, a black hole can carry a spin and charge, but even black holes have their limits. If the spin or the charge of a black hole becomes too large, the event horizon begins to dissolve. If we simplify it, black holes hide a singularity inside. Here, it is thought to be where all the mass and energy of the black hole is concentrated. It is believed to be infinitely dense and have infinite curvature, and where the laws of physics as we know them begin to break down. That's why a black hole looks like a sphere of nothingness. The event horizon is the outer edge of the nothingness. Cross it, and you'll cease to exist in your current state. But when a black hole rotates, it works a bit like the spin cycle of a washing machine. Rotation inherently repels nearby objects and pushes them out of the black hole. But black holes do not allow this to happen because its gravity is so powerful. But if the rotation was able to get strong enough, the effect would win and the event horizon would disappear. But what kind of energy would be released in the process? Where would all that gravity go? Consider an electric charge. It's the same situation. Make it too big and the barrier would dissipate. If we somehow managed to remove the event horizon, the singularity would remain, and objects would still naturally pull towards it. And if you happen to be in the mix, you would still die horribly and quickly. But the vicinity of the singularity would no longer be inescapable. You could get as close as you wanted and then come right back. For all intents and purposes, that's the same as destroying the black hole. But how can we do this? One way to destroy the black hole is to overfeed it. All we'd need to do is overcharge or overspin the black hole. Just toss in a massive amount of objects of small mass but a lot of charge or angular momentum, so that the charge or spin increases faster than the mass. Fill it up like a balloon filling with water until it breaks. But the big physicist debate here is whether or not you can actually do this. Consider a charged black hole. Equal charges repel one another, and the more of the same charges you pack together, the more they push back. Say we have a negatively charged black hole, and we want to overfeed it with electrons, and whose charge is much greater than its mass. The electrons will have electrostatic repulsion, and again, the more electrons tossed in, the larger the negative charge of the black hole will be, and the stronger the repelling force. Once we reach that limit, the electrostatic repulsion will be so intense that it will no longer allow more electrons in.